So, like she said, I'm Chris Gebhardt. I'm a technical marketing engineer in the VMware business unit of NetApp. I touch more than just VMware in my day-to-day business, but today we're going to talk to you about sizing and how important it is for storage. We're really not going to focus on this being a product pitch. We want to talk to you about some of the things we've learned over the years in working with other partners. And basically kind of walk you through how important it is to look at I/O outside of just the number of IOPS a particular desktop can do, because we see most of the cases that come through our support center being directly as an impact of not sizing appropriately, not doing assessments, looking at it just from an IOPS perspective because your favorite broker vendor says, well, a worker desktop does 10 IOPS or 30 or 50, and you will get it wrong. So I want to bring in my experience from a storage perspective to give you some insight as to what we see, how to avoid some of those common pitfalls. And I do want to thank Citrix Tuesday for having a session on why IOPS suck. And we'll kind of go into a little bit more detail. I know they use some of the common material from NetApp and from some of their other partners in that session. But I just want to say that it is important. It was so important that Brian Madden back in 2010 wrote a short book on storage for virtual desktop infrastructure, right? And so this details some of the same things that I'm going to talk to you today. But it was important in 2010 when I gave a session. This is my closing slide of the session. It's still important today. It's actually probably even more important. Ruben Sprugit, the CTO of PQR. PQR you probably all know PQR very, very well. They have some of the best white papers in the industry, Project Virtual Reality Check, as well as the VDI Deep Impact. They've just come out with their next generation paper on storage sizing for virtual desktop infrastructure. This paper basically goes through a lot of what I'm going to talk to today in what desktop virtualization is and what the impact is to storage and why you should care so much. Basically, here's the session and the title that why IOPS suck. Again, thank you to Citrix for pointing this out because it is such an important part of it. They do suck, and today we're going to expand upon why they suck and what you can do to understand them better so that you can architect a solution that meets your requirements while making sure that the cost is in line with what your budgets are. So my agenda is going to consist of much of what's in this PQR paper, but in a little bit higher level, a little bit more focused on the assessment portion, a little bit more on what the industry, what we hear in the industry versus the details. We're going to talk about how what the realities are for desktop virtualization and how storage is impacted by those. We're going to talk about the different workload characteristics during the life cycle of the virtual machine. I'm going to introduce a brand new topic to you today that you probably have never heard, and hopefully that you go and evangelize this because I'm betting on it. I think it's a great new characterization. We're going to talk about some assessment best practices and what you can do with your storage vendors and or NetApp to be able to make sure that you understand what's going on within your environment. And then some of the decisions that you make within your infrastructure, how they impact the scalability, right? Because the architecture affects the end user performance ultimately, right? And also the cost of the solution. So we hear in the industry all this noise, right? NetApp is definitely a part of that noise. We talk about, we just did this benchmark, it was 1.5 million IOPS. Well, that's great, right? What does it mean? Is it for desktop? No. The stuff we talk about when we're talking about 1.5 million desktops or IOPS was a paper that we did around SPC1 or SpecFS or something along those lines. We're not talking about 1.5 million IOPS from a virtual desktop perspective. Our other competition, they constantly talk about, well, this box can do 1 million IOPS. Well, that's great. I'm proud that people are putting out these numbers as a relative comparison. But when it comes to virtual desktop sizing and what actually happens to the storage controller, We're talking about workloads that are much different than 4K sequential reads and writes. We're talking about much different block sizes and much different sequential versus random workloads. We're not talking about industry standard benchmarks. We're talking about users and the chaos that they create within the infrastructure. So while we are all as storage vendors making a lot of this noise in the industry, the reality is this is not what you will see when it comes into your infrastructure. And understanding that is really key to success. So we're going to take a look at how workloads are truly multidimensional, right? Everybody talks about IOPS, and yes, it is a very important part of the overall equation. What they don't talk about most of the time is block size. Block size times IOPS equals throughput. I like to talk, when I talk to my customers, about the amount of work that the storage controller is doing, not how much of any one particular type. What does it take for me to do 10,000 users, right? What are the characteristics of each one of the desktops being incredibly different from, one being different from the other? What does that look like from a workload perspective? The read-write ratio. We have read-write ratios all over the board. You could have a boot storm, a login storm, a steady state for VMware linked clones, for PVS, for MCS, for all these different types of cloning methods that each of the I/O patterns and are different between each one of these. So understanding the read-write ratios for each of the different workloads and making sure that you understand that one workload may have a different read-write ratio, a different IOP requirement, and a different block size is really important in understanding and sizing storage right the first time. Sequential versus random. This is a little bit more difficult and abstract topic to understand from when you're not already virtualized and you have a physical desktop environment, but understanding what type of workload, is it small block random or large block sequential, can significantly impact, and each storage vendor deals with this much differently, right? Some have write coalescing, some have I/O deduplication, some have different technologies that allow you to be able to, benefit from the randomness or stream very nicely for sequential. So looking at this is an important factor when architecting and assessing a virtual desktop workload. Concurrency, pretty simple. How many users are actually working? Are you going to size for the maximum or are you going to size for what's being used? And as well as the different states that the desktops are in. We're going to take a look here at the different workloads. We have boot. This happens to be just looking at IOPS, right? It's very easy to compare, and you see the dramatic differences in the number of IOPS, right, during boot, login, and steady state. With boot, you have a significant amount more reads, right? That's why VMware has come up with content-based recache or the view storage accelerator. That's why Citrix has IntelliCache, to be able to deal with these things in an intelligent manner, to be able to reduce the overall requirement of the storage controller. That's why NetApp has virtual storage tier, right? Everybody has a product to be able to help alleviate this pain, because this is one of the more painful times of the day during the boot. Initial login, well, now we see a 50-50 read and write. Well, is this during profile load? Are you using a profile management solution? Are you offloading that to a storage array so you don't have some of the overheads that I'll show you that you get with using different cloning methods, for example? And then steady state. As you see, this is the quietest workload as far as I/O goes. I'll show you how it can be the quietest, yet the most disruptive, in some coming examples when I talk about some of our partners' success and failures and what their customers are doing. And we'll introduce to you how the low number of IOPS happening in the environment can impact all the users within the environment. So the idea here is one size does not fit all. We have multiple states throughout the day, throughout the week, throughout the calendar month, right, that we need to make sure that we're looking at when we do our assessments, that we're taking a large enough sample size. And if you look at the breakdown, this happens to be steady state. If you look at the breakdown here, whoop, danger, you'll see that 4K I/O is comprised of the most number of I/Os, but when you look at the total amount of work that the storage controller is doing, you'll see that it's actually 5 to 7 times more work is occurring in these large block I/Os. And so the average would be in the 20K range. So when you're sizing your storage, if you're looking at a storage vendor and they're saying, I could do 1 million IOPS, well, was that at 4K or 20K? Because that's incredibly important, and all those multi-dimensional reasons I listed impact the overall scalability of the storage solution. So different workloads have different sizes. And just simply put, if you have a 16 IOP workload, the difference is incredible. It's 8 times the amount of work that is having to happen because the block size changes. So if you look at another example, we're going to take the write cache I/O from some PVS testing that we did. You see here 41% of all the I/O is in the 4K bucket. However, 60% is being done through the actual 64K workload. So I'm actually doing a significant amount of more work with this large block I/O than I am, even though the quantity is significantly higher than the 16%. Right? So these are all just weighted numbers, and we cannot look at purely IOPS alone. And don't be fooled by people that make you look and say, well, it's 50 IOPS, that's just what it is, because it's not. And again, we have different states. We have, this happens to be, during login, steady state, and during boot, or during boot, login, and steady state. And you see the different, the write cache behaviors versus the vDisk, they have different behaviors throughout the life cycle of the desktop. So which one are you going to size for? Right? You can size for the peak, you can size for the peak average, or you can size for just the average. These are all important when looking into sizing storage for desktop virtualization. So now we're going to look at how design dictates scalability. I talk about this a lot because the choices that customers make when architecting their desktop environments truly do impact the scalability of the overall solution. Whether it be the cloning choice that they make or the version of software that they use, each one changes over time. And so first we'll talk about the linked clone. And so one of the features of a linked clone, if we're talking about a VMware technology, and even with MCS, right? MCS uses hypervisor-based snapshots. And so when I'm talking about these types of things, I'm going to bring up this example because it's a VMware example. But the reality is anytime you use hypervisor snapshots, there are different technologies that may or may not be used on the back end to help improve overall performance. So we're going to talk about a linked clone in the grain. The grain is basically what's used, or the smallest available block on a Delta file. A Delta file is that hypervisor snapshot, right? VMware has used 512 bytes for their grain size from the beginning of linked clones and hypervisor snapshots up until now. And this is really problematic for any storage vendor that doesn't have a 512 byte block, because what happens is we get into issues like partial writes, which mimic misalignment but are not misalignment. So if I, for example, and I'll actually show you the example instead of talking about it now. And so writes become partial, and scalability is decreased as the head has to do, the storage controller has to do more work to serve a single I/O. So let's take a quick example of this. So if I have a Delta file, which is my hypervisor snapshot, which is my SCSI redo log, which is the difference between the C drive replica and the virtual machine that everybody, that people get. If I do a 512 byte write, and then come in and do another 4K write, and do a 1K write, well, that's great if you have a 512 byte block. If you don't, for example, NetApp has a 4K, and I write that 512 byte block down, now, when I write that 4K, what happens is it straddles that block boundary. And when I straddle that block boundary, I have to read and then write more data, because I need to understand where that block is being divided. right? So anytime you have an additional a block that straddles the boundary, it's more work, right? And then if I write that, again, that 1K block, I'm now writing into a part of the block. So VMware's come up with a technology called the SE Sparse Disk. It's available with vSphere 5.1 as a function of Horizon View 5.2. It works for native link clones only. So when you use View and View Composer to create a desktop, it will, and you're using VMX version 9, it will automatically use this new format for the Delta disk. It uses a 4K grain size, and it also allows for space reclamation. And I'll put a warning there behind space reclamation, because with technologies like deduplication, not all storage vendors will need space reclamation. And so what now happens is I'm able to then take my writes and stripe them across and actually hit these block boundaries. And while this is great, this may consume a little bit more storage, right? You may waste a couple blocks here, but remember, we're not talking about 512-byte writes. We're talking about storage arrays that now can coalesce all these writes together and stripe them across, right? So this will help significantly reduce the overhead that's involved when we're talking about any storage system that has more than a 512-byte block. Now, cloning impact. I've been talking about this one for a couple years because I don't believe that there's been enough attention on the cloning decisions that people make and how they are deploying their clones and what that impact to storage is. So what you're about to see right now is true of all storage vendors, NetApp included, all the flash guys included, our flash arrays and our flash products included, including DAS. So this is an artifact of what of the technologies that VMware, Citrix, Microsoft have all been using. So cloning can cost you, and it can be significant. The cloning choices that you make in how you're going to deploy your environment have a direct impact on overall scalability, end user performance, and cost of the solution. If we look at a hypervisor-based clone, really what that is it's a virtual machine that's comprised of a replica and the OS disk, or the hypervisor snapshot, aka the Delta file. When you do a read from a linked clone or anything that has a hypervisor snapshot, you have to first do a metadata read from the OS disk to determine, does the data actually live at the OS disk or on the replica? And then you actually have to do that data read. So for every one guest I/O, one read I/O, you have to do 2 storage I/Os. Now for writes, here's where it gets really interesting. One write from the virtual machine equates to 1 metadata read, 1 metadata write if the metadata has not already been written, and then the actual data write. So now I have to do 3 storage I/Os for every 1 guest I/O. So why do you think these flash vendors are very popular? Is, well, they don't care about these little small metadata these metadata writes and the I/O that's generated by that. There's ways to get around this without having to uproot your existing infrastructure and be able to use a system that you already have, or a NetApp if you want. So this is for all storage vendors, including DAS, including flash. You're doing 3 times the amount of work, which decreases your overall scalability. It increases the cost. There are ways around this, and I'll show you that in a couple slides. But doing a pure I/O example, if I had 2 I/O reads, 1 metadata read, 1 metadata write, turns into 4 reads to the storage controller. If I have and this of course is based on a 20/80 read-write ratio. If I have 8 writes, I have to do these 2 metadata reads and the actual data read. I now have to do 8 reads and 16 writes. That turns into 28 IOPS when it comes to storage. So if you sized your storage workload for 10 IOPS from the guest perspective, if you use a hypervisor snapshot-based clone, you now have to use 2.8 times more storage capacity. Why do so many projects fail? It's because they size for this, not understanding this. They say, well, we want to use linked clones because they're storage efficient, right? You have a replica and multiple VMs share that replica. They're also, you use the VMware interface, right? You don't have to go out to a third-party interface like the NetApp VSC to be able to create these clones. So, and then you can use them in an automated fashion, which is great because now I don't have to provision them all up front. I can let View do it, or I can let MCS do it, right? So the reality is that unless you look at the cloning type and the method of cloning, you may get something that goes to storage that's much different. So I size your infrastructure for 10 IOPS like you tell me as a customer. Okay, you don't want me to assess, that's fine. I'll do your 10 apps because that's what VMware or Citrix recommended. I'm okay with that. But tell me what kind of cloning you're doing. Because we have sizers that can take into consideration this. And then when you look at that, you're going to be like, well, I don't want to do that. That's too costly. So let's look at the cloning method as an architectural decision that impacts the end scalability of the solution. So we've done a lot of work on this. We've done a lot of performance tests. We're just going to say, let's say this is 100 IOPS here, right? We're doing 100 IOPS to these multiple virtual machines. And then we take a snapshot of the virtual machine. Let's not even talk about View, or let's not talk about Citrix or anything like that. Let's just take a hypervisor snapshot. This here is the amount of I/O that the storage is doing, or excuse me, pardon me, that the VM is doing. So the minute you take a hypervisor snapshot, the amount of I/O that the guest can do goes down by 80%. And the storage controller has to do a lot more work to be able to maintain that, right? We're having to do, 3 times more I/O to the storage controller to understand the metadata reads and writes. So there is this bridge between what the VM is doing and what the storage is doing that's inefficiency. And then we take a hypervisor snapshot, age it out so that all the data has been written, so now I don't have to do that metadata write anymore. Now I'm just having to do reads and et cetera. Well, performance gets better, and that's great. But the problem is that the storage controller is busier than it was without a hypervisor snapshot. So does everybody see here that the cloning method that you choose does in fact impact storage? I mean, it's pretty obvious. So where does the I/O go? So I took it upon myself to try to understand if I was to take a workload generation utility, login VSI or ROC, run that on a virtual machine and stratify the data, right? Put the profile data on one drive, put the home directory data, put the temporary data on another drive. Where does all this I/O go? If I do it like I'm supposed to, what happens? Well, as you see, the majority of the work during these synthetic workloads, which I'm not a huge fan of, is done to the persona profile, right? So when I boot up the virtual machine and log in for the first time, there's persona and profile data that is being accessed and read. User data contributes to 45% of the data in this synthetic workload, and then 3% goes to the C drive. So what this says to me is that there's a way around around this cost and paying for this cost, right? So that it's not forcing you into all new, brand new architectures. It's do what you're supposed to be doing in the first place. Use the profile management solutions that are available in the marketplace. Don't do persistent desktops using linked clones. I mean, some of the most obvious things that we see our customers doing, despite how many times we've told them, right, that they're going to run into problems. And so there are technologies that we're working with VMware and Citrix to offload that cloning capability to the storage controller. So everybody's heard of VAI, right? It's the ability for VMware to call storage-based clones to be able to hopefully clone faster, clone in a deduplicated or thin type of manner so that it improves overall storage efficiency, improves performance, etc. So VMware is created, and Citrix is working on using technologies like VAI because there's no performance penalty. Right? So you will not see the hypervisor snapshot penalty when you're using storage offloaded clones. There's zero cost in the fact that in our technologies, we use a pre-deduplicated clone. So we don't have to copy as you would a full copy. We basically reference the underlying data blocks. It's offloaded to storage so that you're not having to do the host-based copy. Well, now with 10 gig Ethernet, you know, doing it over a 1 gig pipe was pretty gruesome and it took a long time. It's now pretty fast. So I would say that speed is less of an issue with 10 gig, but it's managed within the broker. So myself, from a NetApp perspective, and I know other vendors have ways of being able to create clones through third-party interfaces to be able to import into desktop brokers and so on and so forth. This allows us to be able to use View, use Citrix from the native console so the desktop admin can do their job, not have to rely on going into vCenter and doing other external operations. And this works for persistent or non-persistent, right? So whatever use case you decide to deploy, offloading the clone to the storage can be used for both user types. And so what you end up seeing is one write to the VM actually equals one write to the storage, right? We don't intercept and we don't have metadata that we have to maintain from a storage perspective. So it gives us better scalability than we have when we are using hypervisor-based clones, and it gives us the cloning capabilities, et cetera. So if you look from a performance perspective, it's quite obvious. We did a test here where we used a hypervisor-based clone versus a clone that was created via an offload mechanism, via VAAI, VCAI, et cetera. And we were able to reduce the storage, the requirements on the storage, the number of IOs from the storage significantly. The amount of, the scalability that we will get out of a full clone using VAAI is much, much better than a pooled desktop that we use with, or floating desktop in VMware terms, that we have with native link clones. So where does this take us? I talk about solutions and designs for solutions because when you look at the whole desktop infrastructure, it's much more than the virtual machines, right? The virtual machines are a very small yet important part of a virtual desktop infrastructure. You have user data, profile data, which are the intellectual lifeblood of a company, right? Without that, they don't make money, right? You want to make sure that you have an infrastructure that allows you to be able to do more than just the virtual desktop. You need to be able to store all these different data types. And so, and because of that, because we have all these different data types, we have different policies and rules that have to be applied to each of these different data types. You know, we don't want to back up or store any of these swap files or temporary data, right? We don't need to replicate that. We want to be able to deduplicate, you know, our end user data. We want to, or our profile data, because that speeds up access to it. Right, so every different type of data has a different requirement when it comes to backup and recovery, disaster recovery, deduplication, you know, snapshots, compression, et cetera, et cetera. And such, each must be treated differently. So we have a platform, and there are other platforms in the industry that allow you to be able to use Metal as a means to scale. And I'm going to come back to that topic. But being able to use a smaller storage controller for smaller environments, larger ones for larger environments, and to be able to provide an infrastructure that allows you to scale horizontally as your environment grows. Being able to serve all these different data types on the right storage when you need it and where you need it. Right? Storage has there's two aspects of it, right? The performance and the capacity, right? Do you want to put your virtual machines on a capacity tier? No. You want to put them on a performance tier. You want to put them on a box that's just for virtual machines, right? Because you don't want those impacting your Exchange or SQL environments. Using a clustered operating system for storage allows you to be able to put your data where you need it, when you need it, move it when it gets hot, put it back when it doesn't, right? And be able to scale out from 1,000 desktops to 25,000, all within the same management construct, right? Managed as a single system, not having disparate nodes. You know, we talk about virtualization and how virtualization takes the physical boundaries, right, and makes them into one aggregated pool, and managed as a single aggregated pool. That's what this does here. So we use Metal as a means to scale. Just like Cisco, right? Cisco has iOS. That's their operating system. They have top of row, or top of rack, end of row, and data center core, all run the same operating system, right? They just use the size of the box to scale whatever the requirements are of the individual network requirement, right? And so we have a product portfolio that allows you to be able to go from the smallest to the largest, including a VSA, which you can run on ESX itself. And then behind that, we have different tiers of storage. Just like everybody else, we got SATA, we got SAS, we got nearline SAS, and we've got SSD. Being able to put this behind any of the storage controllers to give you the IOPS when you need them, and the storage where you need it, is key. And then having one single operating system, a clustered storage operating system, to manage all the different storage tiers, you know, compute tiers within the storage controller. We now have one single operating system that allows us to be able to go across multiple nodes and multiple areas of, and multiple different workloads, served multiple different workloads, right? And so, and then we have this virtualized concept of storage virtual machines, right? Being able to carve up a much larger pool of resources into smaller resources to serve specific workloads. So if you've looked at a storage infrastructure, have you looked at it from an aggregated pool of resources? Right? And I kind of went towards the NetApp side here, but I really want to look at it from a, this is really what people want, right? This is like cloud for storage, right? I don't care where it is, I just need it to perform. I need to be able to apply QoS, and I just want to forget about it. I want to make sure that I have enough capacity, I want to make sure I have enough performance, but I want to aggregate it so I can fully utilize it, just like we did with server virtualization. So, if I now have these layers of abstraction, I can now serve my different workloads from these different units and be able to distribute them across my shared resources where appropriate. My desktops have performance. My profile needs performance. My user data doesn't necessarily, right? It needs to have a lot of capacity. And so having a storage operating system that does this is really key to being able to scale within virtual desktop environments. So all of you have seen this, right? This is the concept where we take and we aggregate hardware to provide resources to applications. So if you've thought of it, the server virtualization, we're analogous to that in how we deal with storage, or how a clustered storage operating system should deal with storage, right? We abstract the hardware, we provide you quality of service, we provide you a capacity and a performance requirement, and instead of having the virtual machines and the CPU and the disk, we give you a capacity and an I/O characteristic. So this is what a clustered storage system should do, is be able to abstract the physical layer to provide you the capacity and IOPS when required. So another function of clustered storage systems is that because of the size and the scale, we're not talking about just a single application on a single storage controller now. We're talking about consolidating your entire, whether it's end user computing environment or your entire server virtualized server environment on the same storage infrastructure. We need to make sure that regardless of what you choose to do, whether you want to upgrade storage, whether you want to migrate storage, it happens non-disruptively. So another key feature of storage and clustered storage has to be that it has to be non-disruptive. So if I have to do a migration or maintenance of this, maybe even these storage nodes, I want to upgrade them to another, to the next version. I want to put in a newer storage controller. I need to be able to do that so that nobody up here cares, right? That's the whole concept of storage vMotion. And the whole concept of vMotion in general is to be able to do things non-disruptively, so at the hardware layer, nobody cares. A clustered storage operating system must do this as well. So that regardless of what I do on the back end as a storage admin, the front end, my customers are not seeing any difference. They're not seeing increased latency. We're not talking about an HA type of scenario where we are failing over to one head and then failing back. We're talking about rip and replacement of critical components within the infrastructure, just like you pull out an ESX host and put in a new one, right? You could do that very easily without interrupting your end users. This is what a clustered storage system must do. So now we're going to talk a bit about assessment and why we need to assess, because I've had a lot of experience with customers that go through a proof of concept, right? They put in a tool like Liquidware Labs, right? Do an assessment, and then something else happens later. Herco Van Brugge of PQR, he's one of their solution architects, came to me 2 years ago at VMworld Europe with a story, and I'm going to try to do as best as I can to tell you that story. He brought me this data on his brand new little Asus tablet converting thing, right? And he said, this is what happened when I went into one of my customers. I went in, we did an assessment. We did 10 days, 15 days of the IT department. And he said, you know what, we were confident because these are what we thought to be the most, the highest, performance requiring unit of the whole thing, of the whole company. And they saw this. They saw what we saw in our earlier slides, which is 4K is the majority of all the I/O, right? 64K is probably the most work. But when they took it from proof of concept with their IT department, which they thought was the heaviest, to production, when they brought in their administrative assistants, what happened is they saw a huge spike in the number of 64K IOs, write IOs, matter of fact. And they were absolutely baffled. Why, when I add my administrative assistants to this virtual desktop environment that are doing Word, PowerPoint, and Excel, am I getting such outrageous performance on the storage controller? Why are they doing so much I/O? What is happening? So they went back and looked at the numbers. Well, what they found out was the majority of them were doing very few IOPS. But as you see, the block sizes were outrageous. What workload does this represent? Anybody have a guess? YouTube. Their administrative staff was taking a lunch break, and thus, I have coined the term, the lunch storm. What happens was, they never assessed this part of it. They didn't understand what was going on. Their administrative staff went to YouTube during lunch to look at videos of their grandkids or whatever. And it was causing a significant impact to the storage infrastructure and the other users that were still trying to work. So I call lunchstorm anything that happens during the lunchtime hour that you never planned for in an assessment, right? Whether it's media streaming or gaming or something that causes a significant amount of change or different behavior than a normal typical business app would happen. So this is one example where you really need to understand what your users are doing, and you need to expand the assessment to a larger period of time and a larger sample size, because you thinking that you're going to get it right by targeting what you believe to be the right group is usually going to get it wrong, and this is a prime example of that. So Liquidware Labs, one of our partners, that we actually, they're a partner, but we actually pay them to be our partner. It's kind of a strange relationship, but basically we provide licenses to our customers and to our partners to be able to do an assessment for 45 days for up to 500 users so that we can guarantee that you get it right. Because without this type of data, I can't tell you what kind of storage you need. I can't give you a price-performing storage controller. So doing the work up front helps save our escalations and your satisfaction at the back end. So make sure, regardless of if you choose NetApp or not, use a tool like Liquidware, even Lakeside, to be able to understand the information before you make infrastructure decisions that could end up costing you 2 or 3 times more, right? Have this information because it's really invaluable when it comes to sizing infrastructure. And so we've worked with them, we pay for the licenses so that our field and our partners can use them within your environments. But the real added value here is that we have a custom report that gives us only the information that we need to be able to put into our sizer to size the infrastructure. So as you see here, we're not just looking at number of IOPS. We're looking at total number of max concurrent machines, right? I don't care about the max number of machines. I care about concurrency, because I'm going to size my infrastructure for concurrency, maybe, and then plus a little growth, right? I'm going to look at the amount of memory allocated, because that impacts the page file, swap file, and storage capacity sizing, right? I'm going to look at the amount of storage allocated, because I don't want to over-provision the capacity. I don't want to allocate 145 gig per desktop, because I'm not going to use it, right? Google's whole model and most of these service providers are all based on oversubscription, right? That they are not giving you 10 gig of Gmail space, right? Because they think that you're going to use it. If you did, they would be in a world of hurt. They're going to give everybody 10 gig, and what it looks like is 10 gig, but the reality is you're only probably going to use a couple hundred meg, maybe a gig, right? So they're betting on it. We don't necessarily in the enterprise want to bet on that people won't use it. We want to get good information, right? And of course their information is historical as it is Google, right? So they understand this. This kind of information gives you an understanding of what customers are using, whether this is assessing a physical or an existing virtual desktop infrastructure. Number of IOPS, number of peak average IOPS. So, while sizing for average IOPS is great, peak average IOPS is maybe one thing that you want to start looking at, because I want to be able to survive the peaks during the day. Well, this particular example, if you look down in the graph, you'll see that something happened between 3 a.m. and 3:15. Probably some sort of Microsoft service or something started to do I/O to the storage controller to gather up data to send to Microsoft. So this doesn't necessarily represent the real world, but what you can do then is hone down that report to your operating hours, right? Or if there is a service, you'll be able to understand that that service is impacting your storage, and therefore you can eliminate or distribute it like you would a virus scan across the entire day. Average throughput, this is the amount of work. What are we doing as far as work from all these virtual machines? Then we go into IOPS, read-write ratios, right? So that we can make sure that when we go to our sizing tools, that we input the correct values for this particular worker. And so we have a sizer, other storage vendors have sizers that allow you to be able to put in the information to get it right, to get the storage sizing correctly, right? Ours, we select the hypervisor because the hypervisor impacts the cloning capability on the back end, right? Do they use VMware snapshots or the Citrix Zen Server snapshots, or do they use Microsoft Hyper-V? This impacts the scalability of each one of them. Select the connection broker, right? Because it gives you the choices, whether you're going to use PVS or MCS, persistent desktops, we can even do things like with XenApp in here to be able to provide sizing for XenApp environments. But this example, we're using link clones. And then are you using a disposable file or persona disk for your environment, right? Because if you are not, we need to first have a conversation. But if you are, we need to understand how much I/O are you offloading from that virtual machine, right? So do you have homegrown applications that basically take and move that data? Your temp files and swap files and everything are stored on that C drive, which is writing to that Delta file or the hypervisor snapshot. So doing this, we can then say, okay, well, 90% of all your I/O is going to go to your profile management solution and or your disposable file disk. So we don't really need to add in that performance penalty for using hypervisor-based snapshots. And then we go through the whole entire worksheet, right? So as you saw in the NetApp custom report, we have multiple different areas here in which we can size for different workloads. So I can have an administrative workload. Liquidware Labs gives us the ability to be able to take and size for different worker types, right? We can put them in groups, and we can size IT separately from administrative staff, separately from developers, so that we understand how to scale those individual components of your business, right? So developers have a different requirement. Instead of aggregating them all into one classification, which can be dangerous, we separate them into their roles and job functions so that when I have a demand for 10 more developer desktops, I know that I need to add X amount of resources to be able to meet those requirements, right? And the same is true for storage. So we need to be able to understand each individual worker type so that we can make sure we have enough capacity as we move forward in growing our business. And so at the end of this, you go through the sizing exercise. What comes out of it is a storage sizing report. This is what, in fact, we take and we bring to our customers to show them what they need for their particular environments, right? And so, we've talked a lot about I/O, talked a lot about block sizes, and the different types of things that can happen in your environment. I'm going to leave on a last example here of how important it is to follow VMware's and Citrix best practices, your storage vendors' best practices, because it can ultimately cost you your job. We had a company in Canada that they had deployed, I'd say 900 seats about 2 years ago on NetApp storage. And they had decided that it was time to give it a second go, right? They had, their CTO, CIO said, okay, we're going to do version 2. Now we got to get this right, guys. Because what had happened was that they had a 3-shift call center. And these 3 different shifts were experiencing problems when one shift was working and the next shift would log in. And then when the next shift logged in, they always had problems. So it would go from, I'd be sitting at my desk, handling my calls. I know the next shift comes in when I'm not able to work anymore. They basically treated VDI like desktops. They did all the things that you shouldn't do, right? They P to V'd, they did McAfee on the client and using the full client, not move or any intelligent antivirus, right? They did all the things that they had done, right, in the physical world, in a virtual world. And this was generation 1. They used local profiles. Don't quite get that. They selectively followed the vendor's best practices. They didn't refresh their floating desktops. And they had a 114 megabyte default profile. So they brought in NetApp. We tried to look at their environment. We tried to see what was going on. We said, well, the storage controller is performing like it should. You're throwing a lot of work at it, right? Well, what it turned out to be was this 114 megabyte default profile, when 300 of their users were logging in because it was their shift, it would have to copy 114 megabyte per user, right, during a very small window when they log back in. And that was causing this login storm to occur during steady state operations for the other shift. And not refreshing the desktops, as it says here, caused a huge amount of storage capacity to be used. Well, to combat that, they decided that they were going to start to deduplicate all this data, which was transient, right? And so they enabled deduplication on the storage controller, thinking that that was going to take care of their capacity issues, when in fact it just caused more storage, a CPU to be used to try to reduce the amount of overall storage. And they got into this cycle. So they called in NetApp. We figured out it was a 114 megabyte profile. It was a matter of, Tom Georgians, our CEO, went to the customer to say, we've got all our guys working on it. We're doing the best that we can. It was to the point where the virtual desktop admin was going to be fired because he was not successful in his second project, right? He did it the first time and failed. Second time, he was failing. Had they done an assessment, they would have caught this immediately. Had they understood what the impact to using and to doing all these different activities had on their storage infrastructure, they wouldn't be in our critical account program. They would have been happy with the first generation architecture. And such, they decided that they would do an assessment based on our recommendations and us providing the tool. They've then expanded the project 3 times greater because they were able to now achieve the density on the systems that we had sold them versus having to go to, to a different platform entirely where they weren't comfortable. So the key to all this is understand that I/O is more than just IOPS. That's one key, but it's about read-write, sequential, random, etc. Understand that the design decisions that you make within your infrastructure, the cloning choices that you make, how you back up and recover, whether you use hypervisor snapshots to back up a particular part of your infrastructure, that all causes more I/O. And make sure that you assess. We provide you tools. I know other partners do this as well, to be able to understand your specific environment and tailor a solution to drive down the cost of the storage for virtual desktops, because we know it's an important and potentially expensive piece. But if you have information, it will cost you a lot less. I can almost guarantee that. So I just want to say thank you guys for coming to the session today. I'll open it up for questions. If anybody has any questions or wants to talk to me, I'll be over at the NetApp booth. But hopefully I've given you an understanding today that, I know Citrix has had a very similar thing on this. Hopefully I've expanded upon that and based on my experiences to give you some information that you could take back with your companies. So thank you very much and travel safe.